Okay, so let's move on to question 2. Consider the following transaction data. We have R2X, R1X, W1Z, R3Z and so forth. This is transaction data 1. Okay, so according to the transaction data above, tabulate the data into a transaction schedule. So tabulate the data into transaction schedule. So before we have the transaction schedule, please understand what does it mean by R2X, R1X, W1Z and so forth. Okay, so if you take a look, R2X, what does it mean? R2X means number 2 here means transaction. So R here is the operation and X here is the data item. Okay, so what does it mean over here? Transaction 2, because number 2, transaction 2, operation R means read. What is data item? Read X. Okay, then if you have W1Z, over here W1Z, what does it mean? Transaction 1, transaction 1, W is write. Write data item Z. So if you can understand this one, then it will be easier for you to tabulate the data into a table, into transaction schedule. Okay, so now first thing first, please determine how many transactions do we have in the transaction data. Let's take a look. We have number 2, transaction 2, transaction 1, 1, 3, 1, 4, then the rest is just repeated. So means we have only 4 different transactions. Transaction 1, transaction 2, transaction 1, transaction 2, transaction 3, and transaction 4. So we have 4 different transactions over here. So now I would prefer if you do the line over here so that you will know that each transaction data over here will be done line by line. So we will tabulate line by line in our table over here. Okay, so let's draw the table first. Okay, so if you have line by line over here, it will be easier lah, and for you to tabulate the data. Okay, so now let's do it one by one. We start with R2X. What does it mean? Transaction 2, read X. R1X, transaction 1, read X. W1Z, transaction 1, write Z. R3Z, transaction 3, read Z. W1Y, transaction 1, write Y. R4Y, transaction 4, read Y. W3X, transaction 3, write X. R4Z, transaction 4, read Z. R2V, transaction 2, read V. W2V, transaction 2, write V. W4X, transaction 4, write X. Okay, and the last one that we have is W4Y, transaction 4, write Y. Okay, so now after we have taken a look, we have done all of the transaction data, and this is our transaction schedule that we have. Okay, so let's take a look on the second question. Draw the precedence graph. Okay, draw the precedence graph by referring to the transaction schedule A1. So by referring to the schedule that we have done just now lah. Okay, so remember, when you have a precedence graph, there must be a directed edge. There must be a directed edge, the arrow. Okay, so the arrow has to be from I to J. So means it has to be on different transaction. I to J. So we have the right to read. So take a look, dia ke bawah. Tak boleh naik ke atas. So means the operation before to operation after. Okay, right to read to write, and write to write. So means on the same data item on different transaction, so then we need to do the directed edge. So what is by directed edge? The arrow. So let's take a look. So now determine how many transactions do we have? 4. So it means what we need to do is we will do T1. Dan apa pun note, kena buat note dulu. T2, T3 and T4. Okay, so by right, if you take a look over here, And if you take a look over here, we have 4 different transactions. So of course, it has to be 4 different nodes that we have over here. Kan 4 different nodes. Kan, so since it is a node, please represent it in terms of node lah. So this is the representation of node. Okay. So now we will do one by one. Kan, we will do the directed edge one by one by taking a look at the transaction data over here. So let's change the color. So now we take a look at read X over here. So since it is in T2, we need to take a look at different transaction, because like I said, it has to be I to J. I to J. So it means different transaction. So if it's now in transaction 2, we take a look at transaction 1. Is there any X? Yes, there are the read X, but there's no directed edge for read to read. So of course the X here is void. Then we take a look at T3. Is there any X? Yes, ada write X. So means read to write, we will have a directed edge. So means T2 to T3 on X, there is a directed edge. So means T2 to T3, so this is directed edge on X. That's the first one. Okay, so take a look at T4. Is there any X? Yes. Kan ada X juga, write X. So means read to write over here. Okay, read to write. So means from T2 to T4, there's a directed edge for data item X. Okay, so is there any other X on different transaction? Tak ada dah. So if there's no, then we know that this one is finished. Then we move to the second line. Read X, data item X again. But this one on T1. Take a look at T2. After this read X, is there any X on T2? No. Is there any X on T3? Yes. Read to write. So means over here from T1 to T3 on data item X. Okay, so is there any other X on T3? No. Is there any other X on T4? Yes, ada juga. So read to write over here. So from T1 to T4 on X. So this one nampak macam tak cantik. So kita pusing sini sikit lah. T1 to T4 on X. Okay, T1 to T4 on X. There's also a directed edge. There's a directed edge on T1 to T4. Okay, so ada lagi on X? Tak ada dah. So means this one is finished. The next one is write Z. The next one is write Z. So take a look at T2. Is there any Z? No. Take a look at T3. Is there any Z? Yes. Write Z. So means T1 to T3 on Z. Just now we have T1 to T3 on X. Kita tambahlah T1 to T3 on Z pula. The next one is on Z. Okay, so is there any other Z in T3? No. Take a look at T4. Write Z. Kita ada read Z over here. So means T1 to T4 on Z. So T1 to T4 on Z. Tadi ada on X tambah on Z pula. Same thing. Tambah. Okay. So now is there any other Z? No. So we can finish with this one. The next line is read Z on T3 over here. Okay. So is there any Z on T2? Tak ada. There's no Z on T1 also. Is there any Z on T4? Yes, but read to read, there's no directed edge. So it means we can finish off this read Z. Finished. Then take a look at next one. T1, write Y. Is there any Y on T2? No. Any Y on T3? No. Any Y on T4? Yes. T1 to T4 on Y. So same goes T1 to T4 on Y over here. Can just add. No need to draw another one because this is just another one directed edge but 3 different data items. Okay, is there any Y? Yes. This one, right to right. But we also already have the Y here, so no need to add another one lah. Okay, so now we have finished with this one. Take a look at the next one, read Y. Is there any Y on T3? No. Any Y on T2? No. Any Y on T1? No. So it means this one is finished. Take a look at write X over here. This one. Is there any X on T2? No. Any X on T3? Yes. Right to right. So it means T3 to T4 on X. And T3 to T4 on X. Okay. So is there any other X? No. We can finish off. Take a look at read Z. Is there any Z on other transaction? No. Finished. Any V on other transaction? No. Any V on other transaction? No. The next one, any X on other transaction? No. Any Y on other transaction? No. Okay, so it means we have gone through all of the transaction data in the precedence graph. Okay, so by right, this is our precedence graph that we have. Okay, so now let's take a look on the next question. Okay, describe the serializability of the precedence graph. Describe the serializability. Okay, so when we want to take a look at the serializability, kan, if you want to take a look on the serializability, is either conflict or non-conflict. Kan, conflict or non-conflict. Conflict serializability means it follows the serializability rule. Kan, non-conflict means it does not follow the serializability rule. Kan, so what is it by conflict serializability? If there is no cycle in precedence graph. Okay, what is it by non-conflict? If there is a cycle in precedence graph. Okay, so now we need to check our precedence graph. Is there any cycle? What is it by cycle? Can what is it by cycle over here? So means let's say we have T1 to T2. Can T1 to T2, tak kisah on data what data item, see it circling over here. Kan, T1 to T2, T2 to T1, T1 to T2, T2 to T1. So by right, there's a cycle. Okay, but if we take a look on our precedence graph, kan, over here, is there any cycle? Okay, is there any cycle? If we take a look over here, T1 to T4, then it doesn't have any cycle to any transaction. T1 to T3, T3 to T4, but it stopped there. Kan, T4 to anyone, to T2 or T1, there is no cycle. Kan, dia take at T3, T3 to T4 only, then T4 no cycle, T4 no out. So by right, if we take a look over here, means there's no cycle. Kan, so by right, what we can say, it is a conflict serializable. Why? Because there's no cycle in the precedence graph. Okay, so that's how we draw the transaction schedule. We draw the precedence graph to get to the conclusion what is the serializability of the schedule. Okay.